Imagine for a second that you're hurtling down a highway in this incredibly state-of-the-art vehicle.
Right.
The dashboard is glowing, the engine is purring, and, the navigation system tells you everything is completely under control.
Sounds ideal.
Yeah, but what you don't realize is that the wheels have actually lost contact with the road. Like your AI is literally driving on black ice.
Oh, man. That is a terrifying image. And, mathematically speaking, it might be exactly what's happening inside the enterprise AI systems you interact with every single day.
Welcome to the deep dive. Today we're wading into this highly technical, incredibly high-stakes debate that recently just blew up in a LinkedIn thread started by Elias Moosman.
Yeah, and this wasn't just your standard tech industry chatter.
No, not at all.
This thread pulled in AI architects, risk consultants, tech lawyers, and they were all colliding over this massive impending problem.
Which brings us to our mission for this deep dive. We're going to explore this really compelling and, frankly, alarming argument.
Very alarming.
Right. The idea that the upcoming EU AI Act might accidentally make software-based AI compliance legally and physically impossible.
Yeah, we're going to examine the fundamental physics of why software fails software, and then unpack this wild, hardware-based solution being proposed to fix it.
Okay, let's unpack this. Because to understand why AI is currently on this black ice,
Yeah.
we first have to look at the massive roadblock that's forcing the entire tech industry to just hit the brakes.
The EU AI Act.
Exactly. Specifically, Article 14.
Right, so Article 14 sets a compliance deadline for August 2nd, 2026.
Coming up fast.
Very fast.
Yeah.
And it introduces this strict requirement for high-risk AI systems to have, quote, independent verification of their outputs.
Okay.
It also mandates that human overseers have to, correctly interpret those outputs.
Right, which on the surface, that sounds perfectly reasonable to me. I mean, you build a powerful AI, you clearly need an independent checker to make sure it isn't hallucinating or going off the rails.
Exactly. You want a human in the loop?
Yeah. But the core of Moosman's argument in this thread, it hinges entirely on that one word, right? Independent.
What's fascinating here is that the drafters of the EU AI Act didn't just casually throw that word into the text. They didn't just accidentally exclude software.
Right.
Independent is actually a really heavy legal term. It's part from 50 years of financial regulation.
Yeah, the sources mention things like Dodd-Frank, MiFID II, Sarbanes-Oxley. I mean, this is deeply established case law.
Right. And in that legal tradition, independent means something very specific. It means the auditor cannot share failure modes with the entity being audited.
Okay, wait, so
You basically cannot have the exact same vulnerabilities as the thing you're supposed to be checking.
let me just play devil's advocate for you listening right now. Couldn't an independent checker just be a piece of compliance software made by a totally different external company?
Yeah, that's the natural assumption.
Right. Like, let's say you buy your AI from Microsoft and you get your compliance filter from some completely different startup in Silicon Valley. Separate companies, separate code bases. I mean, isn't that independence?
Organizationally,
Yes.
but physically. Computationally, not at all.
Wow. Okay.
And that brings us to the physics problem at the heart of this whole debate. Moosman argues that literally every software compliance tool on the market right now runs on the exact same computational substrate as the AI they're checking.
I see. So every tool we currently use to keep AI honest, whether that's, checking a vector database to verify facts,
Right.
or using RREG filters to block bad outputs, or RLHF frameworks to keep the tone polite, it's all just more software.
It's all software. It all uses the same memory, it uses the same cache, and crucially, it relies on Turing-complete chips.
Okay, let's break that down for a second. Why is a Turing-complete chip the fundamental flaw here?
Well, a Turing-complete chip, like the GPU running the massive AI model, or the CPU running your little compliance software, they both use an ALU, an arithmetic logic unit.
Got it.
And the entire purpose of an ALU is to fetch an instruction, decode it, and execute it.
Which makes it inherently flexible, like it just listens to whatever it's told to do next.
Exactly. Too flexible, actually.
Right.
Because these chips are designed to execute arbitrary programs, they can mutate, they can drift. If the data passing through the ALU contains, say, a malicious prompt injection,
Right.
or even if the model's own weights have just drifted through continuous learning, the ALU just dutifully executes that drift. It doesn't know what is true. It only knows how to process the next instruction.
So it's completely blind to its own degradation. And Moosman actually cites Alan Turing's famous 1936 paper here,
It
right?
does, yeah.
To argue that having software check software creates this infinite regress. Like, if the AI can silently drift and hallucinate because it's running on this instruction-based
But
processor.
the software checking it is running on that exact same architecture.
Right, so it's subject to the exact same class of failure. There's this quote from the thread that I absolutely love. It says, "The regulation is silent, physics is not."
Yeah, it's a brilliant distillation of the problem. If your verifier can execute programs, it can be manipulated by the very data it's supposed to be verifying.
Wow.
These attacks cross the chip boundary by design.
It's like, imagine hiring a security guard to watch a bank vault, but the guard uses the exact same flawed pair of glasses as the bank robber,
Right.
who also happens to be hallucinating.
That's a perfect way to put it.
The guard might be from a different agency wearing a totally different uniform, but if their physical perception of reality is broken in the exact same way as the threat they're monitoring.
They aren't actually independent. They just aren't. And this is why this matters so deeply to anyone deploying these enterprise systems.
Yeah.
If your compliance software is in the same physical failure domain as your AI, you literally cannot guarantee the functional role of the system hasn't drifted.
That's terrifying for a bank or a hospital.
You're carrying unmeasured liability on every single inference, every single time that AI generates a single word of output.
Which means when Article 14 demands that a human correctly interpret the output, they literally can't do it.
No.
You have absolutely no way of knowing if the system producing the output right now is still the exact same system you authorized like 5 minutes ago. The context window might have totally drifted.
So if software is mathematically and physically incapable of being truly independent because of this shared Turing-complete vulnerability.
Well, I don't know if this is the solution. I mean, where do we go from here?
Well, according to this thread, we have to drop down a layer.
Okay.
We have to move out of software entirely
Yeah.
and down into physical geometry.
Physical geometry. Wow. And this brings us to a specific patent that got mentioned in the discussion. U.S. 19,637,714.
Yeah, assigned to a company called Theta-Driven. And they proposed a solution that operates completely below the ALU.
So it bypasses instruction execution entirely.
Exactly. It uses something called combinational logic.
Okay, so to understand combinational logic, you basically have to forget about code altogether, right?
Yeah, throw out the code. Instead of running a program to check if the AI is behaving, this hardware uses the physical address of the data in the memory chips themselves.
So in this architecture, position equals meaning.
Yes. The literal physical location of the electrons encodes their functional role.
Okay, here's where it gets really interesting, because I want to use an analogy from the source notes to visualize this for you.
Let's do it.
Imagine a toy box. Normally, a software compliance check would essentially look inside the box, evaluate the toys, run a program, and assign a confidence score, right?
Right. It says, I'm 95% sure the toys are in the right place.
Exactly. And that 95% leaves plenty of room for hallucinations.
So much room.
But this hardware approach, it's like a toy box that physically registers a shake the moment you even attempt to put a toy in the wrong place.
Yes.
Displacement is the violation. You don't need a program to tell you the toy is in the wrong spot because the physical geometry of the box itself prevents it.
And the mechanism they use to actually do this is incredibly elegant. It's a single atomic hardware event, an XOR comparator.
Okay, so for those of us not living in the weeds of electrical engineering, how does an XOR comparator fundamentally differ from the ALU we were talking about earlier?
Good question. So an XOR comparator, which stands for exclusive OR, is this tiny single-purpose logic gate hardwired directly into the silicon.
Okay.
It just takes two inputs. If they're the same, it outputs 0. If they're different, it outputs 1. And that's it.
That's it.
That's it. It doesn't fetch instructions. It doesn't run an operating system. It completely lacks a context window.
Wow. So there's no program running, which means there's no code to hack and no code to drift.
Exactly. Because it operates as a single logic gate, it literally cannot execute arbitrary programs.
Okay.
It cannot hallucinate. It either matches the authorized physical coordinate or it doesn't.
One gate, one verdict.
Right. And the output isn't some fuzzy software-generated probability score. It's a cryptographic trust artifact generated directly from the physics of the silicon itself.
I mean, this completely shifts how we think about verifying AI. Because this isn't about checking what the AI is saying, right? It isn't reading the text to see if a response is toxic or factually inaccurate. It's checking who is saying it.
And that is the crucial distinction here. It's measuring functional role continuity.
Right.
It guarantees that the system producing the output right now is the exact, unaltered system you originally authorized, with 0 behavioral drift.
Right.
because the physical structure of the memory chips enforces the governance.
But obviously, making a claim this massive that the entire multi-billion-dollar AI software compliance industry is built on a physical impossibility, it naturally drew some heavy fire in the LinkedIn comments.
Oh, absolutely. As it
Yeah.
should, right. When you tell lawyers and engineers that their current paradigms are fundamentally broken, they demand receipts.
Yeah, let's play through some of these arguments because my initial instinct, just as a tech user, was pretty similar to some of the engineers in the thread.
What were you thinking?
Well, a commenter named Nick Mabe brought up T's trusted execution environments.
Right, the hardware enclaves.
Yeah, like Intel and AMD already make these, right? So why not just lock the AI inside a secure vault where it can't be tampered with? Doesn't that solve the independence problem?
It's a really common pushback. But Moosman shot that down by drawing a really sharp line between tamper-evident and tamper-proof.
Okay, unpack that.
So, a trusted execution environment might tell you if an external hacker broke in, right? It uses a cryptographic hash to lock down the AI's ways, effectively telling you what the bits are.
Right.
But isolation doesn't stop internal drift. As Moosman pointed out in the thread, quote, weights drift behaviorally inside frozen hashes.
Oh, wow. So even if the AI is inside this impenetrable vault, if it's still running on a Turing-complete chip, it's still executing instructions based on drifted upstream inputs.
Exactly. The call is coming from inside the house.
That's crazy. Okay, another commenter, Pally Simonson, he brought up deterministic compiled inference.
Yeah, the idea that if you put the exact same inputs into the exact same frozen AI model, you get the exact same output every time.
Right, it's totally reproducible. So his point was, if we can prove the AI does the same thing every time, why do we need separate hardware?
Well, Moosman counters that the input plane is actually where the drift lives.
Okay.
Think about how these systems function in the real world. AI context windows accumulate massive amounts of data from users. Automated tools feed information back into the system continuously.
Yeah, it's a constant loop.
So if your inputs have silently shifted, running a deterministic system just gives you a deterministically wrong answer twice.
You're just efficiently arriving at a hallucination.
Exactly.
It's honestly fascinating watching him dismantle these software-based safety nets one by one in the thread. But the comment that really brought this down to earth for me came from Rory Gannis.
Ah, the embedded AI question.
Yes, because he asked about the tools we all use every day. If you're listening to this right now while working in Salesforce Einstein or using Microsoft 365 Copilot to draft an email,
Right.
you are dealing with embedded AI touching regulated corporate data.
And this is where the liability rubber really meets the road.
Yeah.
Because Moosman warns that the verification obligation in the EU AI Act sits entirely with the deployer, not the platform provider.
Wait, let me make sure I have this straight. If I am a bank and I buy a Copilot system from a massive tech giant, I am the one on the hook if it drifts, not the tech giant.
Yes, because any system that adapts continuously through user interaction changes its internal state. The enterprise deploying it is actively shaping that context window.
Oh, yeah.
So you have to prove that the output still reflects the authorized baseline. And right now, without a physical measurement layer, enterprises simply cannot prove that.
Which perfectly sets up the most chilling analogy in the entire thread. A risk consultant named Donald Presnell compared this exact situation to the 2008 financial crisis.
Oh yeah, specifically the credit default swaps.
That is a very specific and honestly a very loaded comparison.
It is, but it makes perfect sense when you look at the mechanics of what actually happened.
Right, because back in 2008, financial regulators basically evaded oversight by intentionally or, perhaps unintentionally omitting the term insurable interest from credit default swaps.
Because they called them swaps instead of insurance, they just bypassed entire regulatory frameworks.
Exactly. And Presnell is suggesting that letting software companies claim they offer independent verification when they physically share the same failure domain. Wait, let me rephrase that. When they share that same domain, it's the exact same kind of catastrophic loophole.
Yeah. And Moosman took that analogy and ran with it. He pointed out that right now, AI liability insurance is effectively zero globally.
Wow, zero.
Insurance carriers literally cannot price the risk of an enterprise AI deployment because there is no physical signal to measure.
They have no speedometer for AI drift. And if you can't measure the risk, you can't insure the risk.
Exactly.
So what does this all mean if we pull all of this together?
If we connect this to the bigger picture, the EU AI Act compliance deadline is only 15 months away. And right now, companies are spending millions buying software compliance tools thinking they're just checking the box for Article 14.
And if Moosman and the physics of shared failure domains are right, those companies are going to find out the hard way that they still carry 100% of the liability.
Because the software they just bought is legally void as an independent verifier.
And you can't just flip a switch to fix this. I mean, the procurement cycle to rip out software compliance and install a hardware-level architectural shift across an entire enterprise, that takes a lot longer than 15 months.
Oh, absolutely. And we even saw a comment from Basil Puglisi pointing out that this isn't just a European problem.
Right.
There's a bill submitted to the U.S. Congress, the Verified AI Inference Standards Act, or VISA, and it's arriving at the exact same structural demand. Regulators globally are converging on the reality that verification evidence has to originate outside the software failure domain.
Yeah, Terry Fleming, another governance architect in the thread, summarized the current state of things perfectly. He said, without an execution layer substrate, governance remains descriptive, not protective. It's just theater with penalties.
Theater with penalties, that is heavy.
It really is. So let's distill this deep dive down for you. The EU AI Act asked for independent verification to keep high-risk AI in check.
Right.
But software, bound by the 1936 laws of physics laid out by Alan Turing, cannot mathematically provide that independence.
It shares the same computational failure domain. A hallucinating system running on a flexible processor simply cannot reliably check another hallucinating system on that exact same processor.
So the only mathematically sound answer seems to be dropping beneath the software, down to the silicon layer, where physical position guarantees identity.
Yeah, where displacement is the violation, detected by a single unhackable logic gate.
And whether you're an engineer building these models, or a legal officer trying to ensure them, or just someone interacting with an AI assistant at work, this debate reveals just how fragile our current trust in AI really is.
We are building the most complex software in human history, and we fundamentally lack a speedometer to tell us when it's drifting off the road.
We are blindly relying on the systems themselves to tell us they are safe. Which brings us back to where we started. Your AI is driving on black ice.
Yeah.
And it leaves us with a lingering thought for you to mull over. Think about how biological brains work.
Okay.
Our own human brains don't rely on abstract, flexible software to govern our fundamental survival mechanisms, like our heartbeat or our breathing. Biology relies on hardwired physical neural pathways. We use geometry, not code, to keep ourselves alive and stable.
That's a great point.
So if our own biology refuses to trust flexible software with its most critical functions,
Why on earth are we expecting a silicon chip to do it for our digital minds?